Hello, my name is Cruz Izu, and I'm going to present a paper comparing small programs for equivalence. And this is a work I've done in collaboration with Claudio Mirolo from the University of Udine. So let's first talk about the objectives of our work. When novices learn to program, they should learn both to read and write programs. So we need activities that assess and develop program comprehension. Why? Because we believe that reading and understanding codes will help them to write better programs. What kind of activities? We use the block model to illustrate the range of comprehension levels. And how many activities we want? Ideally, we will have multiple tasks that cover different aspects of program comprehension. So in this work, we propose a new code reading task in which we ask students to think if two small programs are equivalent. So let's look at what comprehension we can expect from students. On the block model, we have rows in which we have atoms, lines, blocks of programs, relationships between the blocks and the full program. And one of the most common comprehension tasks is tracing. So in tracings, we read the lines, and we have to interpret how the program is executed. So that's what we call AP. So we're working at the bottom level of this hierarchy. Another task used for instructors is explain in plain English task. And in this case, we give our students a program so they can read the list of lines, and they have to interpret the purpose of the program. So in this case, we're working on the function or the purpose, and we're working at the top level. So we can see we have only covering two levels of comprehension. Our new task, the equivalent task, is aiming to look at comprehensions of program execution at the macrostructure level and the relationship level. So one objective for a student is to explore if students can develop their own abstraction of the whole program behavior. And we have two research questions. First one is, are students able to compare similar programs and decide if they are functionally equivalent? Second question is, what level of abstraction they use when they justify their choices. So let's look now at the task and the data collection. So in our task, we provide a program pin, and then we provide 4 different choices. And for each choice, students have to ask, is this program equivalent to P? If yes, they have to explain why it's equivalent. If they say no, they can provide a counterexample. We can also see that in all the variations, we have kept the update statements. So we are updating Vj or Vi in a similar manner, or we are updating the index. In this example, we have program that is not equivalent. And so the transformations of our programs are related to flow. So here we have removed the else, so that will change the flow of the program. In the previous example, we have replaced the if with a while. This task was given to students on their final exam after they have completed 1 year course at the University of Udine. We collected data from 150 students. And the students weren't trained or saw how to do this task before the exam. They were given an introduction. The exam papers were anonymized, and then the 2 authors did an independent deductive content analysis in which we reached 88% inter-rater agreement. So what we expect students to look is at three key insights. The first one I mentioned before is that there is no new update statements. The only thing that changed is the condition flow. Once we realize that, then we have to analyze the flow, and there is two insights regarding flow. The first one is that in program P, I is update when the two vector values are equal. So we either press the update with an equality condition, or we put it on the right place so that when we reach that place, the condition is true. The second insight is that replacing the while-if combination from P with a while-while combination is equivalent, because while the condition is true, we will either loop inside in this while, or we will loop outside with the outer while. And we analyze their insights using two frameworks, Solo and block model. So in Solo, we map the number and the quality of the justifications as follows. If there is no justifications, it's empty. If the justification was very poor, they're working at prestructural level. If they can provide at least one correct insight, they're unistructural. If they can provide two correct insights, they're multistructural. And if they can provide the three insights and also relate them together, link them together, then they're working at the relational level. We also map their explanations into the block model. So let's look at the results of Solo first. In this table, we have the number of correct options. So 73% choose the correct 4 options, but 52% provide the relational justifications for 4 of them. And also another 23% provide relational justifications for at least 3 correct options. So that means that if we add them together, 75%, or 3/4 of the class, were working at the multistructural or relational level, what is a good result. If we look at the key insight in terms of block model, as we expected when we proposed the task, the majority of students are discussing the relationships between the blocks during execution. So they're working at the RP level. A few of them are also working at the purpose level. And when the answer is no, because we asked for a counterexample, then they're either providing a trace example, so they work at AP level, or they are discussing why the relationship between the blocks have changed. So that means that when we look at the top level of abstraction, we have about 60% of the class working at that high level of abstraction. So in summary, our equivalent task was successful in getting students to reason at a high abstraction level. One limitation of the work is we only test one cohort, so we are looking for opportunities to evaluate other cohorts. So we think that this task has the potential of engaging students to develop higher levels of abstraction compared with tracing. And also we have a better performance compared with explaining plain English tasks. So we think this task can help to scaffold them to move from the execution level to the purpose level. And in future work, we want to develop other equivalence tasks that ask students to explore different code transformations. Thank you very much for your attention. We will be available for questions at the conference session.